So good afternoon, everyone, and welcome to this lecture. In this lecture, we are going to deal with
Speed of sound waves.
speed of sound waves, and we had seen the formula for the speed of sound waves. We have seen how speed of sound varies in different mediums, starting from solids to liquids to gases. In liquids, we had seen Newton's formula. He assumed that it was isothermal. His formula was not correct. Then come Laplace and found out the actual formula was gamma. P by rho. Gamma is known as the adiabatic constant, Cp by Cv. And I told you to find out the gamma for monatomic and diatomic gases. Did you find it out? What is the value of gamma for monatomic and gamma for diatomic gases? What is gamma for monatomic gases? Tell me. Gamma for monatomic gases, gases like helium, neon, argon. How much is
2,
this?
sir.
Huh?
2, sir.
2. Gamma is 2.
2 by 5.
Gamma is 5 by 3 for monatomic gases, and gamma for diatomic gases O2 and 2
7 by 3.
7 by 5. These are the values of gamma for monatomic as well as diatomic gases. So you must remember this. So if two gases are given, both are diatomic, gamma will be same, both are monatomic, gamma will be same. If one is mono and one is di, then gamma would be different. And it is, we have already seen the values, gamma RT by M. We had seen this value. So it depends on gamma, it depends on R is the constant. T is the temperature, and it depends on the molecular mass of the gas. Do we remember this formula? Yes or no?
Sir.
Okay. Then we had also seen the effect of wind. What effect wind has on the speed of sound. If wind is blowing in the same direction, the speed of sound increases. If wind is blowing in the opposite direction, speed of sound decreases. We'd also seen what happens if wind is at an angle. You have to find out the component of the wind velocity in the direction or opposite to the direction. Do we remember all of this? Yes or no? No, yes.
Yes, sir.
Okay, that takes me to some questions which we are going to do. And this is the first question. This is the first question that we are going to do. Find the speed of sound in H2, hydrogen gas, at temperature T. If the speed of sound in oxygen at the same temperature is 450 meters per second, and I'll give you 2 minutes to give me the answer for this one to start off the proceedings. 2 minutes you have. How did you get it? This is indeed 1800 meter per second. So remember, the velocity of sound in any gas, any medium is gamma RT by the molecular mass m naught. So I can see that it is inversely proportional to V is inversely proportional to root over 1 by m naught. Yes or no?
Yes,
So I
sir.
can write the speed in H2 divided by speed in O2 will be nothing but root over molecular mass of O2 divided by molecular mass of H2, and this ratio is how much?
4.
This ratio is 4. So the speed of sound in hydrogen at the same temperature becomes 4 times the speed of sound in oxygen. Do we understand this? Yes or no? No, yes. Everyone understands this? We get this? Yes or no?
Yes, sir.
Okay. Okay. Then I'll give you this one. This one. Calculate the ratio of speed of sound in neon to that in water vapor at any temperature. Molecular mass of neon is given. The molecular mass of water vapor is given. Remember, what type of gas is neon? What type of gas is neon?
Monoatomic, sir.
So gamma for that one is 5 by 3.
By 3. Yes, sir.
What kind of gas is water vapor?
Diatomic. Wait.
Diatomic?
Try.
Water. Try. It is polyatomic. For this one, the value of gamma is 4 by 3. So I've given you these values since you don't know them. And I'll give you 2 minutes to give me the answer for this one. Okay, let's go ahead. I think you are stuck probably in the calculation part. So let us not waste any more time. The speed of sound is given by gamma RT by M naught. Here gammas are different, doesn't matter. Velocity in neon N, let me write N, and velocity in water vapor, let me write it as W, will be equal to under root of
Of
gamma of
molecule.
neon divided by gamma of water vapor multiplied by molecular mass of water vapor divided by the molecular mass of neon. This is just you have to read. Uh, so gamma of neon is 5, gamma of water is 4 by 3. So I will have 5 by 4 here, yes or no?
Yes, sir.
5 by 4 into molecular mass of water is 1.8
1.8 into
divided by 2.02. That is the ratio. You can calculate the ratio. I am not very concerned about your calculation. If this question comes, if this question comes in a JEE, they will not be relying so much on your calculation. They will just ask you the ratios and the answer would be given in the form like this. Do we understand this?
Yes, sir.
So this is the answer. Don't have to dig so much into the calculations. Let us move ahead and you can see this question that I'm going to put is from the IIT-JEE of 1999, 2 years after my time, 3 years after my time probably. So you can see the type of question that comes in a IIT, very simple and straightforward. So this is the question number 3 for you. And I'll give you 2 minutes to solve. Find the ratio of speed of sound in nitrogen gas to that of helium gas at 300 Kelvin. I'll give you 2 minutes to give me the answer for this one. So, how are you going to solve this? Speed of sound is equal to gamma RT by M. Speed of sound in nitrogen, let me write it as N. Speed of sound in helium, let me write it as H, will be equal to under root of gamma of nitrogen divided by gamma of helium into molecular mass of helium divided by molecular mass of nitrogen root over. What is the gamma of nitrogen?
7 by 5.
Gamma of nitrogen is 7
Ah,
by 5. What is the gamma of neon?
5 by 3.
Oh, sorry. of helium? 5 by 3. What is the molecular mass of hydrogen? What is the molecular mass of helium?
Helium.
Yes,
4, sir.
4. What is the molecular mass of nitrogen?
14. 28.
Solve it. What are you getting? What are we getting from here? Root over 3 by 5, I guess. Yes,
Yes.
that will be the answer. Maybe the options are given wrong. Not a problem. Do we understand the concept behind
Yes,
this?
sir.
Everyone has understood this concept. I'm more
Yes,
worried
sir.
about the concept. Answers may be right, may be wrong, or it may be a printing mistake. Let's not worry about those things. Everyone got this? Yes or no?
Yes, sir.
Okay, then let me move ahead with the next thing. And we move on to this point, the next point, which is the intensity of sound waves. Intensity of sound waves. Now, we are not going to go into the derivation of the formula because that is not going to serve any purpose. What are we going to do is to remember the formula for this in various forms, and there might be a question that comes in a JEE Main or JEE Advanced based on this. Okay, so remember these formulas in different ways, because remember, sound wave is a longitudinal wave, so you can have a formula in the form of displacement wave or in the form of uh, pressure wave. Now, whenever we talk about any wave, any intensity, we are always talking about the average power over one cycle. Do we understand this?
Yes, sir.
Okay. Now, before we uh, before we write all these formulas, because there are different ways and they might look a lot confusing, we have to understand some relations between the quantities that we are dealing with. For example, the first relation is, let me write the relations here. The first relation that we have to remember, I write the relation here, between velocity v and the bulk modulus. V square is equal to B by rho. Do we remember this relation? Yes or no? Yes or no? Okay. That is the first relation. Then you must remember that delta P naught, maximum amplitude, maximum pressure difference is B K into S naught. Do you remember this? Do we remember this second relation? So I can write this delta P naught also as, since B can be written as rho V square. Let me not make a mistake because I sometimes make a mistake here. Rho V square into K into S naught. Do we understand this?
Yes, sir.
So these are the three relations, because changing these relations, we can get different answers. Now, if you understand these relations, we can write the formula for average power. The first way to write it as delta P naught square into A divided by rho into V. What is A here? A is the area of cross
Area.
section. There is no amplitude here. So remember, A is the area of cross section. A is the area of
Cross
cross
section.
section. Okay.
Yes, sir.
So that is the first way in which you can write it. Okay. The second way in which you can write it, you can write delta P naught as rho V square into K into S naught, and that K can be written, that V and K can be written in the form of omega. So you just remember the formula that I am giving you and keep them. Rho A V omega square S naught square by 2. I have missed that 2 here because this 2 has come. Now this formula that I get is similar to the formula that we got for the transverse wave. This formula that we get is similar to the formula that we got for transverse wave. The intensity of transverse wave or intensity of wave, sorry, the power of the wave. Okay, this is the average power ka formula. If you just go back to the transverse wave, and I will show you that formula, and then you can put all of them together. Anyone remembers the formula for power and intensity of this transverse wave? You have to remember all these formulae, beta, because it's all about how much you can remember and how much you can recollect, and then how much you can reproduce in the examination hall. It all depends on you are remembering the formula. This is the formula that we derived for power transmitted on a string and the intensity of wave on a string. Here A was the amplitude, remember. Here A was the amplitude. Here I have written it as A. Do we understand this? So you have to keep all these formulas together so that you understand how they are different, the sound waves and the transverse wave. If you make a mistake in any of these, well, you will miss 4 marks or more than that. Do we understand this? To keep all those formulas together, I hope you have noted them down together. Yes or no?
Sir.
Okay. Let me now come back. Oops, I've lost it somewhere. I've gone so much forward that it is difficult for me to come back. Sometimes it happens. You go forward so much that it is difficult for you to come back. Anyways, this is where we were, right? So this is the average power. Sometimes they might also ask you, I have not seen this question, the maximum power which the wave can deliver. The maximum power this wave can deliver, just take out that 2 and you will have the formula for maximum power that this wave can deliver. The only difference between these two is the 2 is not present. Okay? Do we understand this? Do we understand this?
Yes, sir.
Now they can also ask you what is the energy that is transferred, so you don't have to worry, just multiply the average power by T. That is the same thing that we had done. That is the same thing that we had done for transverse wave. We multiply power by time and we get the answer. Yes or no? Yes or no?
Yes, sir.
The average intensity, and again, this average intensity is power divided by area. So now, once you understand this power, you will be able to understand what will be the average intensity. What will be the average intensity? You can write it in different forms. You can write it in different forms. The first form that I can see straight away is delta P naught square by 2 rho V. Do we see this form? Yes or no?
Yes.
Now again, from this equation, I can substitute the value of rho and I can write this formula in terms of B and V. In terms of B and V, this formula becomes delta P naught square into V by 2B. Do we understand this? So these are the different ways in which you can write it. You can also divide the first equation by A and you will get the next formula that will be equal to half rho V omega square S naught square. Don't get confused by all these different forms. They are derivable from each other. Do we understand this?
Yes, sir.
You just have to remember any one and you are good enough to do the problems that are going to come. Okay?
Yes, sir.
I'll give you 2 minutes to note them down. Now, whatever we have done is for this type of question that may come. And if you have no idea about the relation between the intensities, magnitudes, you will not be able to do this. So this is only for these type of questions which may come in very rare circumstances. In most of the cases, what I have seen is intensity of transverse wave only come, not for sound waves. But find the displacement amplitude of particles of air whose density is 1.2 kg per meter cube. Density is given. Intensity, frequency, and speed are also given. So you have to relate all those things together and give me the answer. I'll give you 2 minutes. Take a deep breath. Look at what all things are given and look at what is unknown. Unknown is the displacement amplitude. S naught. Do you remember displacement amplitude? So find out the value of that displacement amplitude. I'll give you 2 minutes to do it. Let me do it for you. I think you are got somewhere. Okay, you only have to use two formulae here. Which one? Intensity is given. So intensity can be
Uh,
written as delta P naught square
by
2
2
rho
row
V.
V. Yes, sir.
Yes or no? Okay. From this formula, you can find out the value of delta P naught, which is the maximum pressure difference. It will be under root of 2 rho V I. Yes or no? Yes or no?
Yes, sir.
At the same time, you also know that this delta P naught is equal to B K into S naught. Yes or no?
Yes, sir.
This B is also equal to rho into V square into K into S naught. Yes or no? B bulk modulus not given, but it is equal to rho V square. Yes or no?
Yes, sir.
That's it. You just have to put all those formulas together and you can find out. So from here you can write S naught as, you can write S naught as delta P by rho V square into K. Yes or no?
Yes, sir.
And delta P naught is root over 2 rho Vi divided by rho into V square. K can be written as 2 pi by lambda, and lambda can be written as V divided by F, so 2 pi by lambda. We can write it like this, and V is equal to F lambda, so lambda is equal to F by V. Yes or no? V is equal to F lambda. Yes or no? So
Yes.
I can write 1 by lambda as F by V.
V. Mm.
See, it's just all these formulas put together and you get your answer. So the final answer that you will get is 2 rho Vi divided by rho V square into 2 pi F multiplied by V. That's it. So basically this question was only given for you to understand how these formulas are related to each other. Do we understand these three formulae?
Yes, sir.
Do
Yes,
we
sir.
understand this formula?
Yes, sir.
And do we understand this formula? All these formulas put together and you get your answer in terms of quantities which are known. Get this? We are
Mm.
not going to get this question. If you are going to get this question, it will be in terms of these quantities. Everyone got this?
Yes, sir.
So only these three formulas that you have to remember, which I have written on the right hand side here. You can also add these formulae just for the sake of adding it. Everything. K is equal to 2 pi by lambda. Yes or no? And V is also equal to F lambda. Okay.
Yes, sir.
So you can remember these formulas, put them together, and you will end up with your favorite answer. Shall we move ahead? Everyone got this? What we have done?
Sir,
Everyone understands this, or this is gone above our heads?
we understand.
It's all about, see, there are so many formulas, they are related to each other. What do I do? So many formulas related to each other. You just have to relate all these formulas together. Now we will come to The next point from where there is a
Sir,
yes,
so can't we use the intensity formula directly, like half into rho v omega square s naught square?
yes, you can use that formula also. You just have to find out omega. Yes, you can use that formula also.
Okay, sir.
I did not use it. Yes, you can use that formula also.
Okay,
Average intensity. You can use this formula also. Why did I do it? Well done. Why did I do it that way? Because that thing was going into my head. Yes, you can use this formula. Everything is given. Yes, rho is given, v is omega, frequency is given. Yes, so everything is given. So why not? We can use this formula directly. Yes,
yes.
yes. Sorry, even I did not think it that way. I did not think it. I thought that first we have to find out that S naught. See, my mind was working in that way, and that is why I got it so confused. You can straight away use this formula and get your answer. So from here you can write S naught as 2 times I
Sir,
divided.
what is the answer, sir?
This is the answer, sir. 1 by omega, which you are getting right now. This is the answer.
So we are getting like approximately 10 power minus 7 divided by 14.
The answer that is given here is 6.4 nanometers. Okay, so you can put the value and get the answer. Okay, everyone got this? Well done. I did not think in that way. See, even I get confused with all this formula. For me, the simplest formula to remember is delta P naught square by 2 rho V. That is the simplest I think for it to remember. So I always go on that formula. Anyway, shall we move ahead? Yes or no?
Yes, sir.
Loudness. Loudness. Now, who is loud, who is not? We have already dealt with this. Yes or no? The overall perception of intensity is known as loudness. When you say you are very loud, your intensity is more. The energy that you are putting in the wave is more. Do we understand this?
Yes, sir.
Now, human beings can hear the minimum intensity that human beings can hear is 10 raised to the power minus 12 watt per meter square. Remember this, the minimum intensity that you can hear, smallest intensity that you can hear, that is sometimes known as I naught, is 10 raised to the power minus 12 watt per meter square. Do we understand this? And if the intensity becomes more than 1 watt per meter square, your eardrum is going to get damaged. Do we understand this? Now this intensity is measured. Let me first write it, then I'll give you time to write it down everything. This intensity is measured in the dB scale or decibel scale. Do you know this decibel scale? And it's a log scale. It's a logarithmic scale which is used to measure the intensity of sound. Which is used to measure the intensity of sound, and intensity of sound in the decibel scale is given by this formula. Have you seen this formula before? Which formula? The formula that is coming on your screen now. 10 log I by I naught, and the answer would be in decibel scale. This I naught is the minimum intensity that you can hear, and this I is the intensity of the sound that is coming. So from that, you can find out the intensity of how intense is the sound. Do we understand this?
Yes, sir.
This beta Remember, it's a number. It does not have any unit. So decibel is just a number. It does not have any dimension. Sorry, it has a unit, but it does not have a dimension. Okay? Intensity level decibel, it is a number. It does not have any dimension. Do we understand this? Now I'll give you time to note it down. Have you understood this? Decibel scale?
Yes, sir.
Note it down. So now let's move ahead and solve some problems on this. They are more likely to come rather than those problems. The decibel scale is more likely to come for your thing, for your exam purpose. This is the first question, just to make you understand.
Sir,
Questions are pretty simple. Yes,
sir, in the previous page, what is the dB, sir?
decibel, decibel, decibel. dB,
Is it unit, sir?
yes, it is a unit. Decibel. dB is decibel. Okay. That is the question that is coming up. The intensity is increased by a factor of 20. The original intensity is I, let us say. The intensity becomes 20 times I. What is the change in the intensity level in decibels? I'll give you 2 minutes to give me the answer for this. Everyone understands the question? This is how question of decibels are put. Everyone understands the question?
Sir.
Solve it. So how you should do this? Simple, just use it. Beta, the decibel level, is given by 10 times log of I divided by I naught. Yes or no? First case, the decibel level is 10 times log of I. Let us say the
Then it is
intensity is.
increased by 0.3.
In second case, the decibel level becomes B2, 10 times log of, it has increased by, it has become 20 times. So 20I by I naught. Do we understand this? Yes or no? Huh?
Yes, sir.
B2 minus B1, beta 2 minus B1, 10 times log of this minus that. How much will that be? This is more a question of maths rather than a question of physics. Log of this, log of green one minus log of blue one. What will be the value? It will be log of 20. Yes or no?
Yes, sir.
That's it. Log of 20 is 1.3, I guess. So the answer will be 13 decibels. Do we understand this? You just have to apply the properties of log. It's a log scale, my dear friends. Do we understand this, or this is gone above saying bye bye? Huh?
We got it, sir.
We got it, sir, but you did not give me the correct answer, sir. Smiling will not help. You cannot go to the examination hall and smile and see. Even though the kids look very good when they are smiling, I appreciate your smiles and I love when kids smile. But in examination hall, smiles are not going to work, right? Only answers are going to work. So I hope that this time around, apart from the smile, which is lovely, I will also get the answers, which are more lovely. How many times the pressure amplitude? So this is the reverse question. Remember, pressure amplitude they're asking. How many times the pressure amplitude is increased if the sound level is increased by 40 decibels? Big, 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 big. You shall have 2 minutes to give me the answer for this one. This is the reverse of it. Do we understand now? One, in first case, intensity was increased. We have to find out the change in the decibel level. Here the change in the decibel level is given. You have to find out the change in not intensity. They was pressure amplitude. So remember that. You'll have 2 minutes to give me. These questions are more likely to come, remember. In one of the sessions, I think this one of these questions will come. I don't know which session is yours. Maths is your favorite topic, no? Then why are you not getting the answers? Huh?
Sir,
Yes. This time around, no smiles also. At least last time we had smiles. No smiles, sad faces, and no answers. Why is that so? The only formula you have to apply is this one, beta.
Where is it by 90 times?
100 times. Okay. If I call the first decibel level as beta 1, that is 10 log I1 by I naught. The second decibel level is beta 2. See, this is simple math beta. There is nothing I2 by I naught. It is given that the sound level has increased by 40 decibel. What you got to do is beta 2 minus beta 1 is given as 40. That will be equal to 10 times log of this minus this. And we have done it before also. So that will be I2 by I1. Is it so difficult to get this? Huh? What? So this is 4. Now you can easily do it. That means I2 by I1 becomes 10 raised to the power 4. But this is the ratio of intensities. We had to find out the ratio of pressures, maximum pressure. So delta P of 2 divided by delta P of 1. Remember, intensity is directly proportional to pressure difference square. Do we remember this? Is equal to 10 raised to the power 4. Therefore, the pressure amplitude change, the ratio of pressure amplitude is 10 square, which is 100. Do we understand this, or this has gone above our head saying bye bye, sir? I'm
no,
going.
we understand.
What were you doing then? Tell me. Huh? What were you doing? Sir, chilling out. Huh?
Huh?
We don't know logs.
Sir,
Yes, sir.
I am doing it in the reverse way, sir, like converting 40 into log, like that.
So, the reverse way only I did it. The difference is 40 decibel, bhai. It's not, original is not 40. The difference is 40. First, you have to find out the difference, then only you can equate it to 40, na?
Sir, I have taken like 10 log I by I naught is beta 1 and beta 2 is 10 log I1 by I naught into, sorry, plus 40. Like that I have taken.
India is a democratic country. We can do whatever we want. It may not, it may not have to do anything with physics. It may have to do with our likes and dislikes. India is a democratic country. We are still not in China, a communal country where you are, even if to breathe, you will have to take permission. Democratic country, but that doesn't mean that we'll do anything that we feel like. We have to follow physics in physics class. Do you understand this? Huh? Do you understand physics? How physics is followed? Fatafat, we'll go through this. We have done it three times. But I can be rest assured that you are going to get one question from this. Fatafat. Interference of sound waves, one of the topics that gets some questions. So what happens in this interference of sound waves? You may have two sound waves, two sound systems, and these questions are very popular. Two sound systems which are interfering at a point O. Do you see this? S1 and S2? Yes or no? Then they can give you the equation of the two waves. That is the equation of the two waves. It may be given in this form. It may be given in this form. Then you have to find out the resultant intensity or resultant pressure at any point. Do you remember now how to do this? Huh? The resultant intensity will be given by this formula. Do we remember this? Yes or no? No, yes.
Yes, sir.
And the maximum value is given by a1 square plus a2 square plus 2 times a1 a2 cos phi, where cos phi is the path is the phase difference between the two waves. Do we remember this? Or it has gone above our head saying bye bye, sir, bye bye. I'm going bye bye. Do we remember all these things? So the same things are written in terms of pressure waves. Do we understand this? The same things are written in terms of pressure waves and nothing else. Do we understand this? Huh?
Yes, sir.
Pakka na, sir?
Pakka, sir.
And then again you can have two types of interference. One is known as constructive interference and the other one is known as destructive interference. And you know, for constructive interference the phase difference should be 2n pi, and for destructive it is 2n plus 1 pi. 2n plus 1 pi. Yes or no? Are yes or no?
Sir.
Yes sir or no sir? Again, that was in terms of phase difference. You can write the same difference, same thing in terms of path difference. Do we remember phase difference, path difference?
Yes, sir.
What's the yes sir? Remember, no?
Yes, sir.
Pakka, no sir? You pakka is dangerous. I'm scared of you pakka. You say pakka and then it becomes kacha very easily. Are you noting it down or even chilling out?
Noting it down.
Pakka na? Okay, in terms of path difference, for constructive interference, path difference should be equal to n lambda, and destructive interference, path difference is 2n plus 1 lambda by 2. Remember this? Many times we have done this. Yes or no? No, yes. Huh?
Yes, sir.
Everybody is noting down fastly now. We had seen the formula for maximum pressure difference. Then the formula for intensity will look like this, because intensity is proportional to P square. Do we remember this?
Yes, sir.
Pakka na? Or kacha pakka?
Sir, A square or B square?
Where?
Intensity is proportional to.
I don't know what is intensity proportional to you. You don't remember?
Intensity is proportional to A square.
Here, what is there in place of A? Here, what is there in place of A? Pressure is there. Abhi hal, I had shown you the formula of intensity and pressure 3 times. Hey Bhagwan, here we did a question on intensity and pressure. Here I did so much mistakes and wrote down the formula of intensity and pressure. Here I gave you the formula of intensity and pressure. Still we are asking. Oh God, help me. Oh God, help me. Do we understand this, or this has gone above our head saying bye, 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 bye?
We understand, sir.
If both the intensities are same, I had given you the formula for both intensities same also. Yes or no? No or yes? Huh?
Yes, sir. Yes, sir.
I've already, this is the third time I think we are doing this interference. Yes or no?
Yes, sir.
Hmm. So everyone has noted down the formula once again? Shall we move ahead? Or noting down?
1 minute, sir.
Okay, I'll give you time. Okay, then comes this term coherence, and this term coherence will come probably at the end of the course when we move on to this wave optics. This coherent sources will come in Young's double slit experiment, but coherent sources can come here also. What are coherent sources? Two sources are said to be coherent if the phase difference between them does not change with time. So this is one thing that you have to remember about coherent sources, that phase difference does not change with time, and therefore the resultant intensity at any point in space remains constant with time. And that is what is called as interference in space. Two independent sources of sound are generally non-coherent, but it is still possible to produce two different sources of sound which may be coherent. But for light, two coherent sources of light, if you have to produce two coherent sources of light, they cannot come from two lights, they have to come from one light. And that is why you have Young's double slit experiment. Two coherent sources of sound can still be made from two different sources of sound, but two coherent sources of light cannot be made from two different light sources. It has to come from a single light source, and that is why to make coherent sources of light is a lot difficult, because you have to use just one light to create the coherent sources. But for sound, you may have two sources which may be coherent. So remember the definition of coherent sources, which we'll be requiring in the chapter on wave optics. I'll give you 2 minutes to get going. So now we move ahead and do one question on this interference of waves. A very popular question in JEE Advanced are like this. JEE Mains, it might be a bit more than the level of JEE Main, but if you understand the concept is pretty simple. Figure shows a tube having sound source as one end and observer at the other end. It's a tube. The source we produce sound of frequency up to 10,000 hertz. So up to 10,000 hertz, it can produce any frequency. Speed of sound is given as 400 meter per second. Find the frequencies at which the person hears maximum intensity. The person is going to hear on the other end, and this source is going to produce sound. It can produce sound up till 10,000 hertz. For what frequency will he hear maximum intensity? Na 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 na. You have 2 minutes. How many of you have understood the question? Huh? How many have you understood the question? Have you understood the question? Yes or no?
Yes, sir.
Two sounds. He will hear two sounds. Yes or no? From where? That is the hint to solve. What are the two sounds he will hear? One is this one, ding 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 ding, and the other one is ding 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 ding. Yes. So these two waves are going to interfere, and that is how you have to solve any question of this nature, this is question number 1 in this category, and you will have 2 minutes to get the answer and stay happy. No idea? Then you should get idea. It's a very simple question. There is a green wave and there is a pink wave. You just have to find out the path difference between the two waves. How much is the path difference? This green wave is going ding, ding, and ding. It's
20,
traveling some
20 centimeters.
That's it. That's an answer. See? Question that looks very difficult may be very simple. Now, for maximum intensity, how much should be the path difference? Path difference for maximum intensity. Huh? And lambda, what have we written? We have done interference 3 times. And lambda. So n, oops. So n into lambda should be equal to 20. The value of n can start from 0, but 0 is not possible here because path difference cannot be 0. So 0 is not possible. What is lambda? V is equal to f lambda. Yes or no, no or yes.
Yes, sir.
So lambda is V by f. So n times V by f should be equal to 20. Yes or no?
Yes, sir.
So n multiplied by how much is V given? 400 meter per second divided by 20. 20 should be converted into meters. 0.2. Yes or no?
Yes.
0.2 should be equal to f. Yes or no?
Yes, sir.
From here I'll get the frequency. So if I divide this, this is how much? 2000. Yes or no?
Yes, sir.
So the frequency at which I will get maximum will be n into 2000. Yes or no? So the first frequency will be 1 multiplied by 2000. So 2000. The second will be 2 multiplied by 2000. 4000. Third will be 3 multiplied by 2000. 6000. 8000. And the last one, 10,000. Do we understand this, or this has gone above our head saying bye bye? Was it so difficult? Huh? Was it so difficult? So difficult? No, my dear friends, it was not difficult. Do we understand this? Huh? Or it has gone above our head saying bye bye? Bye bye, I'm going bye bye, bye bye, bye bye.
Understand, sir.
Pakka na, sir?
Yes, sir.
That takes us, my dear friends, to the next topic. Longitudinal standing waves, खड़ी हुई wave, standing waves. Longitudinal standing wave. Do we understand this? How will you produce a longitudinal standing wave? Huh? Sir, I can't produce anything. I am chilling out. Two longitudinal waves, same amplitude, same frequency, same straight line, opposite direction. When they interfere, they will give you longitudinal standing waves. Yes or no? No or yes?
Yes, sir.
And these longitudinal standing waves, the best example we have is vibration in organ pipes. Vibration in organ pipes. That is the best place to see this. Vibration in organ pipe. What is this organ pipe? I'll show you some beautiful pictures of that as well. So we are going to produce these longitudinal waves in this pipe. And we are going to superpose or make them to interfere in this organ pipes. Let me put it here. When two longitudinal waves of same frequency and amplitude travel in the medium in opposite direction, then by superposition standing waves are produced. These waves are produced in air columns in cylindrical tubes of uniform diameter. So these organ pipes are cylindrical tubes of uniform diameter, and these are known as what? Organ pipes. These, my dear friends, are known as organ pipes. Do we understand this? Yes or no? No, yes.
Yes,
These
sir.
are known as organ pipes. And then we are supposed to be dealing with two types of organ pipes. The first one is known as closed organ pipe, and the second one is known as open organ pipe.
Organ pipe.
So the first type of pipe is closed organ pipe. Everyone noting it down? Yes or no?
Yes, sir. Yeah.
Now, when I say a closed organ pipe, it is actually closed at one end. It is not closed at both ends, because if it is closed at both ends, nothing will happen. Do we understand this? It is only closed at one end, and it is open on the other end. So either you can call it closed at one end, or you can call it open at one end. I hope you understand what I'm saying.
Yes, sir.
So this is closed at one end. I hope everyone has written this. Now remember the same thing that we did. This is same as the transverse wave in strings. At the closed end, where you were tying the string, what type of things we are having? We are having nodes, yes or no? And at the open end, string tied at both end, tied at one end. At the tied end, we have nodes. At the open end, we have antinodes. Do we remember this? Do we understand this? Yes or no? No or yes?
Yes, sir.
So this is how the first wave is produced, and the first wave that is produced will be known as the fundamental wave. Yes or no? Or the first harmonic. Yes or no? You can see
Yes, sir.
on the closed end we are having node, and on the open end we are having antinode. Do we see this? Do we see this? Yes or no? No or yes?
Yes, sir.
But remember, whenever we are talking about node and antinode in this pipe, we are talking about displacement nodes. Which nodes we are talking about? Displacement nodes, because for pressure it becomes reverse. If you are talking about pressure, at the close end pressure will have a antinode, and at the open end pressure will have a node. Do we understand this? Because pressure is 90 degree ahead. Do we remember this? Pressure wave and volume, pressure wave and displacement wave. Pressure wave was ahead, yes or no? So in place of node, we will have antinode. In place of node, antinode, we will have node. So now here you can see lambda by 4, lambda 1 by 4 will be equal to L. Yes or no? Do we understand this? Lambda 1 by 4 will be equal to L. Or I can write, in this case, lambda 1 will be equal to 4L, or the fundamental frequency F1 will become V divided by 4L. Do we understand this? Yes or no? No, yes. We understand this, bacha? This is the fundamental of this. Now, this is known as the fundamental or first harmonic or first mode of vibration. Do we remember that? Yes or no? What is the next wave that will be produced? The next wave that will be produced will be known as the first overtone. Yes or no? Yes or no? So for this is lambda 2, 3 lambda 2 by 4 will be equal to L, or your frequency will become F3 4L, or it will become 3 times F1. So this will become your third harmonic. Do we understand this?
Yes, sir.
The odd harmonics are missing. Do we understand this? It's exactly the same that we had done there. I don't see the confidence on your faces. Do we understand this?
Yes, sir.
Ah. This one is the second overtone. Here 5 lambda 3 by 4 becomes equal to L, or your lambda 3 becomes 4L by 5. This frequency becomes F5, 5V by 4L, or 5 times the fundamental frequency, and this becomes your fifth harmonic. Do we understand this?
Yes, sir.
Now we can make the general formula. For this, general formula will be L will be equal to 2m plus 1 lambda by 4. Do we understand this? Where your m stands for the overtone. Do we understand this?
Sir.
Or I can write your lambda as 4l. If you want to remember this general formula, you can also remember this general formula. I'll give you 2 minutes to note this now. Remember, in these diagrams, we have drawn the nodes and antinodes of displacement wave. Pressure is reversed. Do we understand this?
Yes, sir.
Just to give you a description, this is the fundamental mode drawn for a closed pipe. Here on the left hand side is the pressure thing drawn, and on the right hand side it is the displacement thing drawn, displacement wave. Do we understand this? This is the pressure wave, and this is the displacement wave. Remember, if by mistake they give you the, not by mistake, if they give you the pressure wave, remember it's the reverse of the displacement wave. We get this? Yes or no? No, yes.
Yes,
Ah,
sir.
that takes us to the next. What is the next? This was closed organ pipe. The next one is
Open organ pipe.
open organ pipe. When we say open organ pipe, what does that mean? It is open at both ends. Do we
Sides.
understand this?
Yes, sir.
The fundamental wave in terms of displacement would look like this. Remember, displacement wave. We understand this? And I can easily see lambda 1 by 2 will be equal to L. Lambda 1 will be equal to 2L. The fundamental frequency will be V divided by 2L. Do we understand this? First listen to me, then you can draw them on your own. You have to do it on your own. The second wave that is possible is known as the first overtone. We remember this first overtone. And here we can see 2 times lambda 1 by 2 is equal to L, lambda 2 by 2. So lambda 2 becomes equal to L. This F2 becomes V by L, which becomes 2 times of F2. And therefore, this becomes your second harmonic. Moving on to the next wave. The next wave will be known as the second overtone. Yes or no? No, yes.
Yes, sir.
And you can see the wave would be like this. 3 lambda 3 by 2 will be equal to L, or your lambda 3 will become 2L by 3. Your frequency F3 will become 3 times V by 2L. It is 3 times the fundamental frequency, and therefore you have third harmonic. If you want to write the general formula and remember this general formula, can anyone tell me the general formula? L will be equal to, in terms of overtone,
M plus 1, sir.
hmm?
M plus 1.
General formula, if you want to write a general formula. L will be equal to,
Plus 1. M plus 1 lambda by 2, sir. ఎందుకు తీసుకున్నారు
or you can write lambda as 2L divided by n plus 1. N is equal to 0 will correspond to the fundamental frequency. Do we understand this?
Yes, sir. Yes, sir.
This is the general formula for this one. I'll give you 2 minutes to note this down. Then remember one more thing, which is known as this end correction. Now, what do you mean by this end correction? End correction. Now this antinode does not happen exactly. Antinode does not lie exactly at end. They lie some distance outside the end. Okay, the distance where they actually lie to the distance from the end is known as the end correction. It is better to make you understand in this diagram, from this diagram. This is the pressure wave that I have drawn, and you can see this is the end. This is the end. But this node, I'm talking about displacement node. I'm talking about displacement antinode. You can call it displacement antinode, or you can call it pressure node. Yes or no? It lies outside. It lies outside the open end, and that distance E is equal to 0.6 R. That distance is known as the end correction. Do we understand this?
Yes, sir.
For closed pipe has only one open end. Therefore, the fundamental frequency with this end correction becomes V by 4 times L plus 0.6 R. Do we understand? Only one end is open. But for open pipe, two ends are open. Do we understand this? So the fundamental frequency, the corrected fundamental frequency becomes V by 2 times L plus 1.2 R together with end correction. What is R here? R is the radius of the pipe. Do we understand this? Do we understand this? Yes or no? No, yes. Anyone understands this? I'll give you 2 minutes to note it down. Now we'll note down some important points about this, and probably we'll be solving questions tomorrow in the next class. I want to give you time so that you can go back home and see what we have done today. Okay, important points where we are going to relate everything that we have done together. And remember, from this important point, you may have a question coming in your exam, and the question that is going to come in your exam is going to be pretty simple and straightforward. The first important point: a rod clamped at one end or a string fixed at one end is same as a closed organ pipe. Do we understand this? Same, no? Yes or no?
Yes, sir.
Okay. A rod clamped in the middle. If you have a rod like this and I clamp it here, it becomes like an open pipe. Yes or no?
Yes, sir.
If a open organ pipe, and I've seen questions based on this, if an open organ pipe is half submerged in water, so this is an open pipe, and I put half in water, so what happens? It becomes a closed organ pipe, but the length also becomes half. Yes or no?
Yes, sir.
So the fundamental frequency remains same, because in open pipe the fundamental frequency is V by 2L. In a closed pipe the fundamental frequency is V by 4L. The frequency remains same. Do we understand this?
Yes, sir.
Now remember, whenever we are talking about this open or closed organ pipes, we are dealing with longitudinal waves. More specifically, we are dealing with sound. And the speed of sound in all these organ pipes is the speed of sound in air, which always remains constant. Yes or no?
Yeah.
So therefore, since the speed is constant, we can straight away say V is equal to F lambda, and lambda is proportional to the length. We can say the frequency is inversely proportional to length. Do we understand this? Are we able to understand what I'm saying?
Yes, sir.
The same thing said in a different way. For an organ pipe, if you keep the frequency constant, V is proportional to length, V by lambda ka ratio will remain constant. Do we understand this? If frequency is constant, V is already constant, V by lambda ka ratio will remain constant. I'll give you 2 minutes to note this down. Everyone is noting this down, yes or no?
Yes, sir.
Then we come to some questions, and we'll solve more questions in class tomorrow. This is the first one to come. This one. For a certain organ pipe, the 3 consecutive resonant frequency are observed are 425, 595 and 765 Hertz. Taking the speed of sound to be 340, explain whether the pipe is closed at one end or open at both ends. Once you understand this, then you have to find out the fundamental frequency and length of the pipe. Remember, for a pipe which is open at both ends, all harmonics are present. For a pipe which is closed at one end, only odd harmonics are present. Do we understand this?
Yes, sir.
Let's see if you can give me the answer for this one. I'll give you 2 minutes. So how are we supposed to solve this question? Yes. Some frequencies are given. 425, 595 and 765. What are the ratios of these frequencies? Anyone? What are the ratios of the frequencies? The ratio is
5:7:1, sir.
5 is to 7 is to
9.
9. What type of pipe is this?
Closed, sir.
Why did you say open, sir, then? It's a closed organ pipe. Now I have to find out the fundamental frequency. This you can see is the 5th harmonic. Yes or no? This one is the 5th harmonic. Yes or no? So 5 times F1 is 425. So what is the value of F1? The first harmonic.
85. 85, sir.
85, sir. See, it was so simple, sir. Multiply, divide, there was no physics involved even. F1 is 85. Now knowing F1 is 85, can you now tell me the length of the pipe? I'll give you one more chance to redeem yourself. Students are like cash vouchers. Given chance, and if you put the code correctly, answer will come. Yes. Open organ pipe. No, this is closed organ pipe. Fundamental frequency is known. What is the length of the pipe? Speed of sound is also given 340. This fundamental frequency will be equal to how much?
F is equal to 340 by 4L.
So V by 4L and V is 340.
Yes, sir. 340 by.
From here, you should be able to get me the answer of L. How much is L?
One.
L is 1 meter. That's it. That is the answer. And these are the answers for this one. So simple. What you got to do is you got to just understand that these questions are going to be very simple, and we expect questions from these standing waves, whether it will come from standing transverse wave or standing longitudinal wave, that we don't know, but in some session there has to be a question from this. No doubt about that one. So what we are going to do is we are going to solve more questions in the next class. Till then, you will get time to go back and see both transverse wave, both longitudinal waves, and we will do more questions on this and beats. So that will be covering in the next class. And then the last thing that will remain will be Doppler's effect, that we will cover in the next class. So by next class, we should be over with this topic on waves, and then we'll move on to thermodynamics quickly and try to wind it up as soon as possible. Okay, so do we understand this, everyone?
Yes, sir.
Okay, so I'll see you tomorrow in tomorrow's class, and we will take things forward from that class. Take care. God bless you.
Thank
Everyone
you,
understood
sir.
what we did
Yes,
today?
sir. Yes, sir.
Go back home and just have a reading. Okay,
Sure, sir. Thank you, sir.
bye beta.